Есть.
Так, сначала говорю на русском, потом говорю на английском. Всем привет, меня зовут Ангелина, руководитель отдела техподразделения. Перед тем, как начать, пожалуйста, участники Zoom, подпишитесь своими реальными именами и поменяйте имя сверху. Участники в офлайне, пожалуйста, поднимайте руки, если есть вопросы, рады вашим вопросам. После этой лекции будет уже кофе-брейк, где мы сможем поболтать, пообщаться. Кто не был у нас, провести еще экскурсии, следующих вопросов. Okay, let's start. Hello everyone, my name is Angelina, and today we will have a very interesting lecture and workshop with Alexandr Petrov, please.
Alright, shall we start? I suppose. Okay. Good evening, people. Thank you for coming to the talk. For the lecture. Anyway. I will be talking today about the DevOps from the experience perspective, and yeah, so basically it will be about the role itself, it will be about the philosophy, the risks that we have in DevOps usually, and the tools we use. So that's basically the topic we're discussing now. Okay. All right. So who am I? Just to establish where I come from and why this topic. So my name is Alex. I'm from this city very much. So I left for Germany around 6 years ago. Before that, I left for Almaty, studied there. I went to Germany, worked in several different companies. It was a fintech startup. That was basically writing out loans for the small and medium-sized businesses. Then it was a pharmaceutical company, company projects. One was an AI startup, which is a very, very popular topic today. And the fourth one was Taxistriga, my last place of work. It's a massive corporation, something like 16,000 direct employees. So yeah, pretty big place. Yeah, there's a lot going on. And yeah, after 6 years in Germany, I decided to just come back home and contribute to the development of the community here. And ideally, maybe establish some working ties with how people like to say that the West, and yeah, maybe hire some local people too, or just live and enjoy and contribute. That's it. So yeah, back then, 9 years ago, I was planning to become a network engineer. So I was studying Cisco exams. I'm not sure if you know the Cisco company, but there is a company which does networking and networking exams called Cisco. So I was really absolutely sure, something like 10 years ago, that I will be a network engineer. But then my university demanded at the third year, or fourth year actually, that we do internship in software engineering, and I started software engineering. And I actually liked it, so I did software engineering for like 6 years, intertwined with system administrator and network engineering work, and that's basically why I would call myself a DevOps, because that's where DevOps is, on the intersection between the system administration and software engineering. Actually, more than system engineering, more like system engineering and software engineering. Let's call it that way. So yeah, let's actually talk about what is DevOps. And to understand what DevOps is, why we actually need it, let's look at the history. And here you can see how it was before DevOps. So the classic legacy companies where they just had, like 3 departments, and one department was developers, and the second was testers, and sysadmins, and it was actually the case that they were just developing something, shipping it to the other department. Another department was doing something like tests, and then they send it to the sysadmins, and at the latest stage, they would find out that the code is actually incompatible for the web use, and they would send it all the way back. So, and that would take months of development. So it was costing an insane amount of money. That's why developing software back then was incredibly expensive. You could do that only if you had a handful of nerds to do that, who just had a lot of free time and a lot of money to do that. So that was, of course, a big waste. And people decided, let's do something about it. And that's how DevOps philosophy got born. So the DevOps philosophy is basically focused on bridging the gap between the operations and the development. That's the DevOps. Yeah. So what is the DevOps philosophy exactly? The DevOps philosophy goes on about how to unify those processes, ideally also remove the friction points between the developers and the operations people, and also to increase the time to market, speed up the cycles where you ship something, you get the feedback, you adjust something, and you reship it, etc., etc. So ideally, the case was to teach the developers to understand the servers, understand the modern deployment processes, and and to, on the other hand, teach the operations people, the system administrators, and network administrators to understand at least a little bit of development, like what are the challenges, what are the important points to really speed things up a little bit. The other important aspect of that is automation, because when you physically ship code from one department to another, it's not very efficient in the sense that it took before quite a long time, because people, as I understand it, I wasn't alive during that time, so I'm not really sure about this. But from what I've heard from people who are like 30, 40 years in the profession, they said that they had to write it on the floppy disks, and then they had to pass it to another department, and they would load it on their computers, they would test it, and then they would ship it further to others, to the system administrators who would try to actually deploy it somehow. And yeah, so they literally operated on physical copies were very much advanced in this regard today. And DevOps philosophy is exactly about this. So to automate such things, let's not write it to the floppy disks or the CDs, let's, for example, create packages or the containers, and let's ship them over the network to the servers, and then let's try to run them. And if they don't, then we can automatically get we have shorter feedback loop that goes back to the development immediately, so they know it doesn't work. If it works, amazing, great, then we can ship it, which is also pretty fast. Yeah, and this basically facilitated the last important topic, which is about continuous improvement. If you have shorter feedback loops, you can operate way faster. You can make improvements much more precisely and much better targeted at the needs of the software and your customers. Therefore, that's basically the idea. And here you have a picture which basically shows how it is. So the people build something, code, plan is not their code. So it's they plan it, they code it, they build it, test it, they release it, deploy it, operate it, monitor the thing. And this is all continuous. So it's not broken into the blocks, it's actually happening all the time. Aftermath of the DevOps adoption, because in the world of business, if you do anything, it should make any sense, because it doesn't make any sense in the sense of money, then you shouldn't be doing that probably. So here are 5 important metrics which I got after pretty fast research with ChatGPT. Amazing thing, just gathers all the information from the internet into the bullet points. I checked, of course, that it actually makes sense. So yeah, but this is what it is. It is realistic. So time to market from months to under an hour, absolutely realistic metrics. So from the previous picture where they were literally shipping for months, you can now deploy a major release in under an hour easily. So maybe even 30 minutes, 50 minutes, doesn't matter. Depends on the size of your software and the cycles and what kind of infrastructure you have. This is anyway infinitely better than before. Deployment frequency increased, yes. So if you can deliver faster to the market, means that you also have a higher frequency of deployments, which is also good because you get to move faster, you get to validate your ideas with your customers and your development team. Then you can also monitor what is better, what is worse, and what are the pain points, what are the good parts, etc., etc. The failure rate, also important metric, because again, if people do not understand how other parts should be working, for example, most people do not understand how software people should be working, vice versa, there's a pretty big chance that once you have something done, it will actually not work. If they understand each other, at least a little bit, with the help of tools or specialized training, that means they are going to ship better and with lower failure rate. So this is absolutely true. And yeah, this is actually massive saving. So imagine a team does like 10 major versions in half a year, and before it's like 2 of those versions would be completely not acceptable for the market. And now maybe like 1, sometimes 0 of them. That is actually a huge improvement money-wise. And even business people who don't like that stuff, the technical stuff, I've noticed that, and that is great. Mean time to recovery, also important metric, because software breaks. So it's like, if anybody thinks that you can just deploy something to the, I don't know, anywhere, and it'll just run indefinitely, well, not very much the case. It will break at some point. Unforeseen bugs, infrastructure outages, imperfection of the underlying technology and the foundations, that will just happen. And the ability where you can just roll things back and you can monitor them, you can see what went wrong and when, why, and ideally also have a automated rollback is actually pretty amazing. So there is a number of 6,500 X improvement. That is true, and customers see that. For example, if an outage happens before it was like service went down, well, it will be down for like a week. Not very good. For example, if you need to order a Yandex taxi from one place to another, and then they say basically, well, for a week we will not be able to do that. Not very great, right? And now you can just recover it completely in a matter of minutes. That is amazing. Yeah, team efficiency, very, I would say this is quite controversial. And team efficiency is, of course, more like a subjective metric, but removing the issues and programs when you want to deploy something, build things, is actually reducing the what's the word, frustration when you try to do that. And lower frustration directly equalizes into the higher satisfaction. So you like your job, you don't burn out. At the end of the week, maybe you want to do something fun and not just lie on the floor and think about your life choices. So yeah. All right. Let's go further. Further, we have emergence of the DevOps as a role. Why I wanted to put that as a separate? So you see, DevOps is not a role, and a lot of people in software and in the IT business in general do not get it. It's like you don't have a dedicated DevOps person. You have a person you have an engineer who can apply both development and operations and understands what it is. But it is too difficult to operate it. For example, if you're hiring for this, or you want to just explain it to the investors, like, hey, we are hiring someone, and why are we doing that? Well, because they do DevOps. What is DevOps? Doesn't matter. It's just good. Okay, fine. That's how DevOps role emerged. And DevOps role is essentially, there are some pretty words I wrote here, but essentially it's somebody who exactly knows both the operations and the software engineering. And this usually DevOps engineers come from some other background in the software world. So usually it would be a software engineer who just learned networks and learned servers and learned things, and now can do something about it. So, and also understand how software engineers work, and importantly, can coach software engineers so they can write better software, which is amazing. Or they come from a system administrator or a system engineer background, a network engineer background. Those are people who know pretty well the infrastructure. They know how things work, they know what things work, they know how they connect, they know how to fix them. And they learn some programming, they speak to the developers, they do the courses, they understand what it is. And here they can approach the process from another perspective. The other ones are QA and consulting. Yes, it happens, although not very frequently. But in the end, the resulting engineer, doesn't matter from which background, would be somebody who could coach both the developers and the system administrators or the engineers on how to apply DevOps philosophy, and that is the important part. All right, let's move to the next slide. Sub-roles in the DevOps teams. So DevOps doesn't exist for the first year. What usually happens, the sub-roles have emerged. So we have a classic DevOps engineer who will be handling basically everything. So it's like a full stack engineer of the DevOps. We have a cloud engineer, somebody who specializes on the clouds, for example, because sometimes DevOps also gets basically associated with the clouds, but that is very much not true. You can do DevOps on the prem, you can do it on the cloud, you can do it anywhere, and not all DevOps people even know the cloud, which is surprising. But yeah, that is what it is. So cloud engineer would be exactly specialized in working with the clouds. They would know what clouds are, how they operate, how to optimize the costs. Actually, those guys, they will have also like subdivision of something like cloud performance engineers and FinOps. So it's also this way. But let's not deep dive too deep into this because this is the most important part. It's actually my favorite type of engineer, to be a full stack, to just understand as much as you can, because it helps. And the security engineer, compliance and cybersecurity audits is very, very important thing, which is very often not that emphasized, especially in actually in businesses of all sizes. So would it be a big company or a medium business or startup? Security is important because compromising the security will immediately compromise the reputation of the companies, customers. Data conscious customers would not want to really report that. I mean, imagine ChatGPT would have a major link with all of your chats, and that would be very interesting, right? And it will go somewhere in the open access. That would be just a complete disaster. I think we would just have a major mental breakdown for the whole planet. All right. So, what are the responsibilities? What the DevOps engineer actually does? So, automation of the releases, absolutely yes. That's what the DevOps people do. So the idea is to build the pipelines for continuous integration and deployment, and automate as much as possible, and shorten the delivery cycles, etc. Managing infrastructure, usually done now over the infrastructure as a code tools. The main ones would be Terraform and Ansible, and actually there are so many now. There's Blumini, there's AWS CDK, there's Azure version of a thing. There are so many, but those are like Terraform is good when you want cloud cross-platform, and Ansible is usually when you need to manage the servers. It would be a virtual machines or the physical servers, something of sort. Monitor performance, Prometheus and Grafana are basically the state-of-the-art industry standards. There are also other tools. Tools we will discuss a little bit later. Therefore, I will be delving deep right now. And yeah, participation in on-call, yeah, that happens too. That is very fun. When you have to wake up at 2 a.m. because something doesn't work, so to prevent that, you really educate your developers to do things safely and ideally not on the weekends. So yeah, this is also important, and collaborate across teams. So this is actually the cornerstone. So when you are a DevOps, it's actually your job to understand and to make sure that your developers understand how things will be deployed, and basically you're the operations person usually. So basically that's it. You have to coach people. That's your job. Okay, common risks. This exists. So first of all, culture of resistance, usually applicable to the big corporations, but not only big corporations. For example, it's actually fun. So previous generations in the big corporations didn't really want to do DevOps because it is the usual case. We've done it this way for 20 years. We don't want to change a thing. Why shall we do anything else? Let's not do that. And then you have to actually explain that. Well, actually you do because that's the situation right now. And right now there is a pretty comical evidence of an emerging class of engineers called vibe coders. And the fun thing about vibe coders is that they also don't want to do DevOps and understand where things go. It's like, what are the servers? Like I asked my ChatGPT to do myself a website. Why do I need to understand how the servers work? Well, that's for old people like me, I guess. Well, that's it. So this is important, and this is a real situation. Tool sprawl also happens. There are so many tools right now, and when companies really post their requirements for the vacant, for the open places in the DevOps role, they just provide everything. The feeling is that they just find all of the words they found anywhere in their system, just put it there, just for the sake of it. Then you have to manage this thing and kind of operate that. So this is a pretty real risk, because understanding all of the tools which you could use in the DevOps processes is an issue. So there's pretty real pressure to bring the amount of tools down and use more stable and more and the tools that you actually need and not just, could be cool. Yeah. This is also important, but it is important to have a balance between those two. Security vulnerabilities, the same idea as the security issues. Yes, important. Technical depth, yes. Maintaining things, pipelines, configurations is important. And yeah, it is important. That's all I can say. Risk mitigation strategies. Yes, those are basically the solutions to the problems I just talked about. So foster culture. It should be, well, it's basically the company thing. So the company should actively promote to really look into the DevOps and try to do that. This is how you overcome the issue where people just don't want to do things. Standardized tools, exactly what I said. So to choose consistent, stable tool set, which doesn't change very often. But I would say also important to maintain the balance to integration. Security best practices, yes, there are things which actively monitor for the security gaps. And yeah, allocate time regularly for the maintenance tasks. Very hard to explain to your project manager, but very important too. About the tools, so we are moving to the tools section. And let's talk about CI/CD. There you have 4 of them. Name, so Jenkins, GitLab, Circle CI, Azure DevOps. Those are probably the most popular ones. There are 10 or 15 of them. You don't need to know all of them. It is enough to know maybe, well, Jenkins is kind of old, although still very widely used. GitLab CI, important. GitHub CI also exists, also popular right now. AWS has its own. I think they were trying to decommission the thing. So basically, what is the continuous integration, continuous deployment? It is basically a tool to take your code and somehow put it somewhere where it's running. Basically, that's it. So that is the idea. And how it does that? Well, there are different sources. So usually you would use some kind of Git system, and your tool will just pull new commits and new releases and then try to deploy them where you need to deploy them. Or you could also use another sources like zip files if you want. Maybe, probably not. But yeah, that's what's gonna happen. And then you basically have some kind of logic. You have a server which runs for a specified amount of time, and you can define what this will do. Will it build the container, or will it use an SSH, or will it send it somewhere else, or will it run some security checks, or will it run tests? This is all you can define. So CI/CD tools are usually pretty flexible, and yeah, that's basically where you define your logic for the continuous integration. Infrastructure as a code. Very important thing today. I would say this is the #1 thing which employers actually ask when you try to get a DevOps job. So first of all is the Terraform. Terraform is open source, sort of open source, with the enterprise support, multi-cloud provisioning and automation framework. Because it is a framework, so basically what it does, there are a lot of cloud providers today, AWS, Azure, Yandex, Google Cloud, Hetzner, IBM, and some more. And not to have to use their own tools, or even worse, the console commands where you just click things together. You would use Terraform. And that is basically the thing. Terraform is good because it supports most major clouds, and I think all the major clouds and some of the smaller ones. So it's basically like a multi-tool for the infrastructure as a whole. Ansible, again, it's very good stuff for managing the separated servers. So if you have the servers, either physical or on the cloud, you can manage them via Ansible, which is very convenient. It's that way. There are combined development kits. So there is a main separation between the Terraform and the cloud development kits, because you see, at some point, people realize that Terraform is actually pretty limited, because it is basically just a descriptive language. I'm not sure if I want to go into the programming paradigms right now, but descriptive language does not allow you to define the classes. It does not allow you to call the methods. And generally, it's just basically you just write down what you want, but you cannot really execute some sort of a logic. So you are very limited what you can do with descriptive languages. You can do pretty much everything, but usually not in the way which a developer would like it. And developers like things that interact with each other, which use the usual patterns and classes and constructs for the software engineering. Therefore, tools like AWS CDK have emerged, and those things are amazing in the sense that you can write your code and you can write your infrastructure in the same repository. So you don't have to even divide it. You don't have to put it anywhere on the clouds or containers. I mean, you don't have to, like, literally, you don't have to make separation. You have one repo, one point of truth. You can deploy it everywhere. That is just great. And actually, there is a new tool called Columni, which I have learned relatively recently about. And Columni is basically like Terraform. So open for all clouds and supports major clouds, but operates quite like AWS CDK, cloud development kit. So in the software engineering way. And that is an amazing tool, gets traction very fast. So if you are looking to get into DevOps, look into Columni. Definitely good stuff. Docker and Kubernetes, yes, the staples, basically when you develop right now, anything at all, you would usually put it in the container. It's like literally anything you build, a web server, a business logic application, something like parallel processing databases, literally anything you would usually run into the Docker or some other container. Of course, there are other ones, but actually the market share for like 95% of them is Docker, so Docker is the most important what we need to know. Kubernetes is basically a very sophisticated platform, which I think originated from Google to manage the Docker containers, or just general containers. So, yeah, basically that's it. So Kubernetes in itself is actually quite complex. So it manages the clusters, it manages the nodes, and basically we have the setup of the Dockers, put it on some servers. Those servers now interact as if they were one. Not really. I mean, it is complicated. So there are many things, but the main idea is that it gives you a centralized management platform for your containers, and you can manage your applications from there. That's basically the idea. Okay. Essential DevOps tools, monitoring and logging. Yes. So when you deploy something, it is paramount that you actually monitor what's happening. So not only because it looks nice and you can build the dashboards and show it to the net, it's working, but also because things break, and when they break, you want to comply. And yeah, here you have the main tools. So Prometheus is basically an industry standard in getting the metrics and like health tests. And then you have a Grafana, which is for building beautiful dashboards and showing how things work. And then you have ELK stack, which is basically all structured about the log manager. Actually, it was very surprising for me that for the logs, you need a whole tech stack to manage the logs. But this is the case because, you know, when you have just one server of logs, that's okay, that's manageable. But when you have like hundreds or thousands of servers with logs, that you have a generation of 20 gigabytes or like 100 gigabytes of log data per 2-3 days, that is actually a massive problem. And navigating that is very difficult. If you do not have some centralized systems, so ELK stack, that's where it comes from. Datadog is a nice stuff in the sense that it's a SaaS solution, so software as a service solution. It kind of stands out because it's a unified solution for all of those things, but it's basically plug and play. So you give them credentials to your cloud, and you can just connect to them. I don't want to make them advertisements, but you know, it's like I was at the conference and they spent a whole hour explaining to me how amazing they are now. Yeah, guys, you are pretty amazing. So yeah, unified stuff. But those are basically industry standards. That's where you want to focus your attention if you want to do DevOps. Yeah, so for the conclusion, I suppose we are also time-wise more or less at the end. So I would say as a conclusion, it is important to understand that DevOps is not really a role, it's not just some person on your team who just manages the stuff. It's also you, if you are a developer, a QA engineer, a project manager, but really you could focus on adopting the DevOps culture and the philosophy to really ship faster, ship better products, and ship them in a more frictionless way, so you would enjoy your job, and yeah, and you can achieve better results this way. That being said, thank you for your attention. We have 17 minutes.
Yeah.
And I would like to answer some questions.
20 minutes. Yeah, because we start in 5 minutes. Yeah.
Okay.
Okay. Question, please. Okay.
Thank you for the lecture. It was very interesting. But I have a question that is a bit of topic. You said you have worked in Germany. I'm interested in what languages and what other languages did you need to work there.
So, if I understood the question right, if you want to go to Germany and work there, which languages and technologies you need to learn, right? Yeah. The same ones you learn here, pretty much. Because you see the tools are very global right now. So, for example, I check with the colleagues frequently, mostly on LinkedIn, what they use in our companies like Kaspi or but you know, Kaspi, Kolesa, so they use tools which are very modern. And those ones which were in the presentation, they also suffice. So if you want to work in Germany as a DevOps, probably you need the same tools as here. Programming languages, Java is a staple. If you want to go work at a big corporation, probably you need Java. You also probably want to know German. If you go to Germany, English would suffice to some degree, but German basically opens like 50% of the career opportunities for you there. Other ones are in English, and the competition is much fierce when you can only access one portion of it. So that's it. Any more questions?
Did you learn German?
Yes, I learned German. Das ist eigentlich eine interessante Frage für mich, würde ich sagen. Also, warum nicht? Dann kann ich auch meine Deutschkenntnisse demonstrieren. Jetzt, I have learned German in our Goethe Institute Center. They are actually pretty good. The rest of it I learned at my Catholic German university. They're also actually pretty good. So yeah, that's where you can go.
So which level did you achieve?
Sorry?
Which level of German? There is A1,
C1, I suppose.
Appreciate your election. I have a question, like which sub-role in DevOps is hard to fill and why?
Which sub-role is hard to fill and why?
Yeah.
The most important sub-role to fill is, the hardest role to fill in, I would say some specialized cybersecurity person, so the security one, because you see, it's not very fun stuff. It's not so much about, it is to some degree about fighting the bad guys, not letting them have access to infrastructure, but it's also very much a very bureaucratized process. So you write papers, you make an audit, like what is where and why, and what are the issues and how they're happening. And the other part is that it is hard to fill, but there are also not many openings because not so many people need not so many security engineers are needed as much as the general people who just could make it working and who combine the knowledge to do that. So I would say they're all hard to fill if you are aiming to just get a foot at the door, I would suggest aim to the general full stack DevOps. And at some point you can specialize into security, and then it will be very hard to replace it. Or it would be easy to find a job, let's say. But probably it would be consulting roles because it just makes more economic sense for the person who's very niche skill to go from company to company and advise them on what to do.
Okay, thanks. And the second question, your experience, which which problems the company face when they're implementing the DevOps, and can you explain which common mistakes they face?
Well, I would say the first and the foremost problem is having somebody who can actually do DevOps. So first of all, right now it's not a drastic situation. There are quite a lot of people who can do the DevOps and who know the processes, who can establish that. But there you have the classic issue of a senior engineer. For example, I'm pretty sure. By the way, are you just starting in the profession, or are you a student?
I'm junior data analyst right now, but
Nice.
I'm interested in DevOps. So
yeah. Okay, so the thing is, I see a lot of posts on the LinkedIn where people are fear-mongering that AI will replace all of the engineers, etc., etc. And that's basically it's hard to get into the profession. But overall, I would say the shortage of senior people come from junior people at some point, is still very drastic. It's so I would say the biggest problem companies face at the DevOps stage is actually finding the person who can advise them and ideally establish the processes and ideally also sit through with them and guide them through implementation and adoption. So this is the biggest hurdle companies face. The other ones include like the infrastructure costs, the tools, because you also have a learning curve. But when you have a good DevOps person who can establish processes, you're basically 90% done.
Thanks.
So I don't have any profound knowledge in DevOps, and I have heard about it some once. So, and my question maybe might be slightly strange and awkward.
Go for it.
So, if DevOps can span the both development and operation groups, why DevOps engineer can substitute both of them, like both the development and operation groups?
That is actually a very good question, and DevOps engineer absolutely can, actually. So this is the interesting part, because DevOps engineer can actually write software or can do the operations. That's basically that's the whole idea, and that's what makes the DevOps engineer valuable. I am pretty sure if you check the salaries for the DevOps engineer in comparison to just plain system administrators and software engineers, they have higher rates. And it is precisely because DevOps engineer needs to combine all of those skills. So it just doesn't make a lot of economic sense usually to make DevOps engineer do everything, because then it's called a full stack engineer. And companies hire full stack engineers, but they just don't have a lot of money and they just need to fill in the positions. So sometimes, well, that's the thing. If you are a full stack engineer, then you are probably a DevOps. That's kind of it. Not necessarily, but probably. That's how it is. But in the well-equipped teams, it just doesn't make a lot of sense, because DevOps have enough to do, and they just specialize on facilitating this communication and tools and information. So the answer to the question, they absolutely can. It just doesn't make much sense to do so. Better to leave it to the people who specialize.
So, okay, thank you.
Okay, question? Yes.
So we talked about security sub-role, and I have a question about two another roles. Before this lecture, I thought that cloud engineer is DevOps just without knowledges of operation system like Linux and maybe security knowledges. But you say that DevOps don't know cloud services, right? But what do they do? Yeah.
So you see, it is important to differentiate the tools from the profession. And the DevOps person can absolutely work without cloud. So you have just a server farm, which is managed by, I suppose, maybe it's an open stack, where you basically make a local cloud, sort of, or you can operate bare metal servers. So basically, all you need for this is just network, and that's it. You operate over network. Cloud is not necessarily something DevOps should know, but yeah, I mean, probably cloud engineer knows DevOps, probably, not necessarily also, but it is what it is. And I would say just generally it's very subjective. The division of roles, they also differentiate from company to company. One company, software engineer could be a complete DevOps. In another company, DevOps could be doing the development. So yeah, I would say I would just differentiate the cloud from the whole profession, because you do not necessarily need the cloud for the DevOps. And if you are using cloud, also you do not necessarily need the DevOps actually. But usually you probably do need DevOps on the cloud. Yeah.
Question?
Online.
Online, yeah. We have a question from online, question from DLR. How does your ground in system engineering and software development help you as DevOps engineer?
That's basically the foundation. So to be an actual real DevOps engineer, you knowledge from both the development and operations. And there was a time when I worked as a system administrator. There was a time when I was working purely as a software engineer, and some point that just merged into DevOps. And that's what I do. That's how it is. I suppose. I hope it's a satisfying answer to the question.
Okay. What are the most common mistakes companies make when we try to implement DevOps?
I would say important mistakes company make is that when they try to adopt the DevOps processes, they just treat them as old school system administrators and kind of expect them to use the same tools, do the same processes, where they literally put a stamp with done code, ship it there, instead of making the shorter feedback loops and using tools for this. But I would say most mistakes happen actually at the management level, because management sometimes does not necessarily know what DevOps is, how to do that. And by doing so, we minimize the advantages of the DevOps, and that's the most common mistake. So also coaching managers on how to do the DevOps and not try to put the processes like an old school is also important, because if you don't do them, I would say completely, that you will lose on the advantages. That's not what I think. But still, if you are trying to adopt it, then it's already better than not trying to adopt it. So again, I don't want to bash on anyone, but that's how it is.
Interesting question. It's still hard to. What are the key difference between DevOps engineer and cloud engineer and security engineer in practice?
Well, as I said, I have added them as sub-roles. So basically, the difference is that DevOps is a general term, and I would say cloud engineer and security engineer and just general DevOps engineer, or like sub-roles and specializations of those people. Yeah, that's it. I mean, it's not really very important. I don't focus too much on that.
Okay, thank you.
We got another question.
So you mentioned lower error rates and faster deployment. Which outcomes was most significant for you in your projects?
I would say reduced failure rate is most important to me, because as somebody who had to redeploy the servers at 2 a.m., I very much like when things don't break too much.
Okay, got it.
We have from online. Why did you choose DevOps and why Germany?
Germany, first of all, because it was available. I'm not sure if you know, but Germany has a lot of programs, especially for people who want to study there and work there. Germany has a very big cooperation channels with Kazakhstan, where they also supply these scholarships and support people to move there and work there, and also maybe at some point come back and share experience and knowledge, just goodwill between the countries. I would say it's just, yeah, it was available, it was there, that's why I chose it. I would say 5-6 years ago here, salaries were also way lower in the IT hub in Germany. And today, it is actually the case that if you specialize in some things, and if you build the channel of the clients for the work, you can actually earn here more than you have earned in Germany, than you could earn in Germany. Because, because I would say bureaucracy is a big hurdle, which really undermines the entrepreneurship and being able to cooperate on more flexible basis. Germany is all about order. And order sometimes demands inflexibility. It changes, not the order part, but I would say Germany finds the ways around that. But I also see the potential of Kazakhstan, so I decided Kazakhstan is more interested in that regard at that point in my life. And what's the other part? DevOps. Why DevOps? Like,
Yeah.
because it pays better.
Because what?
Because it pays better. I could have done software engineering, I could have done just plain system administrator work, but DevOps just pays better. And I can do that. That's
Yeah, from IT to DevOps for you. Okay, we have 4 questions now.
amazing.
From Lucian. Do you believe every development team needs a dedicated DevOps engineer?
Good question. I would say dedicated, probably not every team. So when the team is big, probably they do. But in my experience, it was actually the following way. So I had a project at Experience AI in Berlin, and we didn't have a DevOps person, so dedicated person, just don't have. We didn't have one. But we had, so the whole structure was that, the whole team structure was that we are full stack engineers, and then we decide what we specialize on. And because I need the operations and development, I can specialize into the DevOps, and that's it. So not every team needs a dedicated one, but if team grows big enough, probably dedicated one will just emerge there, or will be hired from somewhere. That's it.
Which CI/CD tool do personality prefer and why? GitLab, CI, or something else?
You know, I try to be agnostic in the sense that I don't choose favorites. So it's like, no, I like our data, I absolutely have favorites. GitHub is the best, and everybody should use GitHub. That's a joke. Actually, GitHub is also pretty cool. Other tools are also pretty cool. I would say the deciding factor really is how well it integrates with your particular landscape of the tools of the company. Because if you try to bring something from Atlassian in your suite, when you have everything on the GitHub, that is probably not a good idea, even if you like Atlassian. So vice versa, if you have everything Atlassian and you try to bring GitHub, you just lose a lot of synergy on integration. So yeah, I would say I have some favorites because of the usability, user experience, and the general performance. But I would always choose the right tool for the job, or at least try to do so. And I think that's the way.
Okay, thank you. Your experience, which sub-role in DevOps is the most difficult to fill and why?
We already had this question, and I answered this is really huge.
Okay. And last question. You mentioned faster development and slower error rate. Sorry, yes. Which of these DevOps outcomes was the most impactful in your projects?
So we have repeating questions now. I would say for me personally, the failure rate, again, because I don't want to be awake at 2 a.m. and fix stuff.
Okay. What question? Yes?
How rarely DevOps is like you uses ChatGPT?
These days I use ChatGPT, but you know, it's like how I use ChatGPT. I don't actually call it AI. I generally don't consider it AI because AI intelligence much more than just processing a ton of text. But you know, ChatGPT is like an advanced documentation tool, so you don't have to literally like read through pages and pages of documentation. You just ask ChatGPT exactly what you need, and it finds that. So I use it often as a better Google search. That's it.
We know that it's sometimes making some mistakes, and during your work progress, did it hurt your process, working process?
Actually, yeah, sometimes it tells absolute nonsense. It's like, you know, and the dangerous part about LLMs in general, so ChatGPT, plots, other ones, the DeepSeek, etc. The biggest danger of them all is that they give you sometimes wrong answers with a lot of confidence. They're like, yeah, dude, I got you, that's the way. And you say, that is absolute nonsense. That is not right. You just see that, and from students, you know that's not true. And then it says, yeah, you are absolutely right. And starts to tell you the same thing. Need some other thing. It's just so annoying sometimes. Sometimes, actually, I'm so annoyed by ChatGPT. I actually just open old school documentation and start reading what actual person wrote.
Okay, thanks.
Okay. Question not online we have. Thank you very much. Thank you. And go to our coffee break.
Yes.